Okay, the final classification method we'll talk about in today's lab is k-nearest neighbors. And although a different classifier to LDA and QDA in terms of using sklearn, it's quite similar. So the difference is really in the actual method we're going to use. That's this first class we call from scikit-learn. It's the k-nearest neighbors class. We construct a classifier using the one nearest neighbors. The rest of the code where we fit and predict on training, predict on test, is identical, and again, compute the confusion matrix. So we see here that using one nearest neighbors, which is going to be a very flexible classifier, so like possibly having high variance, it may suffer from overfitting, and indeed, the classifier is not very good. It has about 50% test accuracy.
As bad as you can get.
Yes. Okay. Let's see if we change the number of neighbors if we do any better. Using 3 neighbors, we get about 53%, which is better, but not quite as good as the discriminant methods we saw before.
So these k-nearest neighbor methods are extremely adaptive and flexible, but they can overfit, especially on small data sets.
Yes. So it would be nice to be able to choose this using in a simple fashion, and that's what we'll do next. So we're going to use a slightly different data set. This is the caravan data set from the ISLP package, which talks about whether we can predict whether people purchase caravan insurance or not. And it's noted it's a very imbalanced classification problem because there's only 6% that actually do purchase, unlike the stock market data where the up or down is going to be roughly 50% if it's basically noise.
In case you didn't know, a caravan is a camper van in Australia and New Zealand and South Africa and other colonies.
And I guess it would be an RV in North America. Okay, so we'll just create, we'll use all of the features besides the purchase column to create some features. And now, unlike the stock market data where we just had lag 1 and lag 2 as our features, it turns out there are many different features in this caravan that are measured in slightly different units. So since the k-nearest neighbors classifier uses distances between points, if one variable has very different units than another variable, it will tend to dominate the distance. So for that reason, we're going to use we're going to standardize the features before classifying. So for that, we'll use a scalar or the standard scalar from scikit-learn, and this is an example of a transformer. We saw transformers in chapter 3 in linear regression in the model spec. That was an example of a transformer, and if you remember, the transformer, it's something that we mentioned is used to sort of derive features from existing features. That's a typical application. So we call its fit method on a set of features. Notice there's just the set of features in this fit method, not a response, because it's taking features to create new features. And having fit the transformer, that finds all the parameters. In this case, the means and variances needed to scale the features to mean 0 and variance 1. Then we can apply it to the features using the transform method. Okay, so we'll use our standardized features for k-nearest neighbors. And we'll also do a split into test and training. And we'll use the test data with various different neighbor sizes to try and choose a good number of neighbors. Okay, so this is just like the stock market k-nearest neighbors example, except of course we have different data. This is the caravan data and not the stock market data. We see with one nearest neighbor, we get about 11% accuracy, which is better than 6%. 6% is what we would get if we had a reasonable estimate of what we would get if we had no features, if we just used an intercept in the model. So we see some improvement, but not always, not a great improvement. Okay, so let's talk about choosing the number of nearest neighbors. This is an example of choosing a tuning parameter for an estimator, a common task that we'll see in other examples coming up. So what we're going to do is fit the k-nearest neighbor classifier for varying numbers of neighbors. And we're going to choose neighbors from, here we have a for loop, and we're going to loop over the neighbors 1 to 5. And just in case that's the range 1 to 6 actually really gives us only the numbers 1 to 5. That's how the range function works. Okay, so what we're going to do is we're going to, within the for loop, do essentially what we had done above. That is, we're going to fit on the training data, predict on the test data, and form the confusion matrix. And then we'll compute the accuracy, and we're just going to print out, with this statement here, print out the accuracy as a function of nearest neighbors. In later labs, we'll make a plot of accuracy or mean squared error as a function of tuning parameter. Here, we're just going to print it out. Okay. And so one small thing that if you noticed earlier, it took us 3 lines to form the confusion matrix. We're avoiding a line by looking at the fit predictor and directly calling its predict method. It's only 2 lines to fit and form the confusion matrix. Okay, so let's see. For this test and training splits, we can see most of the number of neighbors achieve around 14 or 15% accuracy, with 4 neighbors being a kind of anomaly that we haven't really investigated, but it is a notable difference between the other ones.
It only predicted 4 would rent.
Yes.
So it was strange. And you can get this with nearest neighbors because it's a very noisy classifier.
Yes. Okay, so that wraps up what we were going to talk about in the lab today. There are a few more sections in the lab that we encourage you to go through, one including Poisson regression that we will leave to you to do offline.